Everybody, and once again we're back together, and now we're looking at how to determine the volume of a gas at STP. All right, so now one thing that I want you guys to remember is that, well, when we're looking at the word STP, what it simply means is that we're talking about standard temperature and pressure, right? That's what it simply means, standard temperature and pressure. Okay, now if we're looking at standard temperature, well, standard temperature is said to be as at 0 degrees Celsius, which when we represent it in Kelvin, that's 273 Kelvin, right? So that's the scale that we usually use in chemistry, right? So that's standard temperature. But what about standard pressure? Well, we usually call it 1 atmosphere or atmospheric pressure, right? This is the pressure at sea level, right? So this one is actually said to be at approximately 100 kilopascals, but more specifically, we can say 101.3 kilopascals. Now, ladies and gents, what we know according to Avogadro's law, or Avogadro's law, right? I almost said Avogadro's constant. That's a different thing altogether. According to Avogadro's law, Avogadro simply says that 1 mole of any gas, right, will occupy the same volume at the same temperature and pressure. So what we do know is that at STP, 1 mole of any gas, what we refer to as the molar volume, will be 22.4 cubic decimeters per mole, right? In some regions we use liters, okay? So decimeters and liters are exactly the same thing, right? So we say that 1 mole of any gas at STP occupies 22.4 cubic decimeters per mole, right? Now, in this case, what we're going to do, ladies and gents, is just know how to determine that volume of the gas, right? If we were given mass, right, how would we use that volume to determine the number of moles? All right, how would we use rather the number of moles to determine that volume? All right, so I want us to quickly look at a question together, right? So they say to us, calculate the volume of carbon dioxide formed if 60 grams of ethane burns in excess oxygen, right, according to the following unbalanced reaction. Now, I want you to please note, ladies and gents, every time that we're looking at stoichiometry, what we said is that we need to convert everything into moles, right? So what did they do here? They've given us mass, right? But this is the mass of the reactant, ethane, right? So they've given us mass, we need to convert it into moles, right? So remember, we say number of moles, that's mass divided by molar mass. I always call this the roadmap in stoichiometry, right? But if it's given in moles, we can just directly use this. Now, once we get the moles of the reactant, or in this case, what we have, then we can use our ratio, our molar ratio, and this is where we need to make absolutely certain that our formula or our reaction is perfectly balanced, right? So we are going to use this and use the ratio, and in this case we use the ratio to determine the moles of what we are actually looking for, right? So we're going to use that to determine the moles of carbon dioxide that we're looking for, and ultimately we are going to actually determine the volume of that gas using the number of moles, okay? So we are going to get the volume in that case, right? So let's do that. So firstly, right, the first thing we need to make sure of is that we've got a balanced reaction. So let's balance it first. So I'm going to just change my color there so that we can ensure that we know what we're doing. Right, so on the left hand side, I've got 2 carbon atoms. I've got only 1 on the right hand side. Remember, when we don't have a number, a subscript, we assume that is 1, right? So I've got 2 on the left, but I've got 1 on the right. So remember, when we balance, we put the coefficient. So I will put 2 there to make sure that we've got 2 moles. Right, so in this case, we've got 6 hydrogen atoms, right? On the right, we've got only 2. How can we make that 6? We multiply by 3, right? So we've got now carbon and hydrogen, right, is taken care of. All we need to do is make sure that our oxygen is balanced as well. So we're going to say 2 multiplied by 2 for oxygen, right, on the right-hand side. We've got only 2 on the left, but on the right, we've got 2 times 2, which is 4, plus another 3 times 1, that gives us 3. So we've got 7 atoms of hydrogen, of oxygen rather, on the right-hand side. Now, how do we make sure that we've got 7 on the left? So we multiply by 3.5, which is 7 over 2, right? 7 over 2 multiplied by 2 gives us 7. However, ladies and gents, please remember that the coefficients that we have in chemistry that we use can never be a fraction or a decimal, right? So what we need to do now is multiply throughout by what we call the lowest common denominator in this case. So we know that that's going to be 2. So multiply everything throughout by 2. Okay, so we know there's a 1 there, right? So 1 multiplied by 2, that will give us 2. 7 over 2 multiplied by 2, right? Remember, that's 3.5. That gives us 7. 2 multiplied by 2 gives us 4. And 3 multiplied by 2 gives us 6. And we know that we've got a balanced reaction right now. Okay, right, now let's answer the question that we had. What were we given? We were given the mass of ethane, right? So we're going to say number of moles, that's mass, divided by the molar mass. And remember, we now need to use our periodic table, right? So we know that carbon, right, has a molar mass of 12. Hydrogen has got a molar mass of 1, right? But now, how many carbons do we have? Now, ladies and gents, please always make it a point that when you calculate the molar mass, you never multiply by the stoichiometric ratio. Okay, please never do that. So in this case, my mass is 60 grams, all right? And I'm going to now calculate the molar mass of ethane. That's 2 carbon atoms. That's 2 multiplied by the molar mass, or the relative atomic mass of carbon, which is 12, plus, in this case, I've got 6 hydrogens, so that's 6, multiplied by the relative atomic mass of hydrogen, which is 1. Okay, so in this case, we've got 24 plus 6, which will give us 30, right? So this will be 60 divided by 30, and that will give us 2 moles. All right, so now that we know that we've got 2 moles of methane, or rather ethane, right, we need to find out how many moles of carbon dioxide do we have. So what we're going to do, ladies and gents, is say, well, from our formula, right, we always go to our formula. So remember, we now found out the moles, right, from mass to moles, and now we are going to use our ratio to find out the moles of what we want. And what are we looking for? We're looking for the volume of carbon dioxide. So I'm going to use the coefficients that I have. 2 moles of C2H2 gives me 4 moles of carbon dioxide, right? So in this case, then I'm going to say, well, if I've got 2, then how many moles of carbon dioxide do I have, right? And you'll see that that actually gives us 4, because that's actually the ratio that we have, right? So we cross multiply. N multiplied by 2 gives me 2n. 2 times 4 gives me 8, right? And I'm going through this for the sake of you understanding even if we had different values, right? So that will be 2n, right? Divided by 2, that will be n. And if I divide by 2 on both sides, then I know that I've got 4 moles of carbon dioxide that will be produced. Right, ladies and gents, we're looking for the volume. So what formula do we use? Simply say number of moles is the volume of the gas divided by the molar volume. But remember, we said at STP, right? So we are looking for the amount of carbon dioxide at STP. So in this case, I'm going to say, well, the number of moles that I have is 4, right? I'm looking for the volume, and I know the molar volume is 22.4 at STP. Now, ladies and gents, if it was at a different temperature or a different pressure value, right, we would be given a molar volume that is not the one at STP, right? So the moment they give us different conditions, they need to give us the molar volume at those conditions. Right, all we're going to do, ladies and gents, is just cross multiply. So V would be equal to 4 times 22.4. That will give us, that will be 89, right? That should be 89.6, isn't it? Okay, let's just verify that. 22.4 multiplied by 4. That's definitely it. That's 89.6. And remember, in this case, we will measure that in cubic decimeters, right? And if it was given to us in, let's say, milliliters or cubic centimeters, then we would need to convert in that case. But we'll look at that another time. Ladies and gents, that is how the cookie crumbles, right? We'll look at another example when we meet again next time. Otherwise, from me for now, I'll see you guys next time. Shop, shop.